Alright, so we're on to the last video of our volume. This one's probably going to be a bit longer than the previous ones because we're going to be looking at some exam style questions where we need to find the volume of a composite shape. So a composite shape is a shape that is made up of two shapes either added together or taken out from one another. So I've got 3 examples to go through. On the right hand side I have all the formula that I am given in the exam, and let's just jump straight to it. So a curtain beam is made up of 2 identical spheres on either end of a cylinder. So to start off with, I'm just going to get my highlighter out and I'm going to highlight the fact that I've got 2 identical spheres and the other shape I'm being told is a cylinder. So a lot of the time it does read out exactly what shape you are looking at, because then instantly the fact that I can read that I've got spheres means I'm definitely going to be using this formula here. And the fact I've got a cylinder, either I can remember my cylinder formula or I can look at my volume of a cone and remember I can just remove that third and that's my formula. So then the next little bit, this just gives a bit more context to my diagram. The radius of the cylinder and the spheres is 3 centimeters. So I am just going to highlight that. So radius is 3 centimeters and the length of the cylinder is 30 centimeters. So that's all the information that I am given, and I've been asked to calculate the volume of the beam. So to start off with, let's just break it up into the individual shapes. So I need to first figure out what the volume of just one sphere is to start off with. So using my formula which I'm given, I am told that the radius of it is 3 centimeters. And so putting that into my calculator, gets me 113.09. And because I'm not done with my final answer, I'm just going to do 2 decimal places more than what I'm going to do for my final answer. And that's normally a good rule to go by. So I know the volume of one sphere, so that means 2 spheres. I'm just going to take my answer and I'm just going to times it by 2. So that's going to give me 226.164 and 7 there. Okay. So now I want to find the volume of my cylinder. So I'm just going to break that off a little bit just so things don't get too messy. So my cylinder, and again remember I look at my cone if need be and I just remove the third and that is my formula. I went to put the third in there. So I've got pi times my radius of 3 times the height of 30. So that gives me 848.2300. And so then my total volume in this shape, I can clearly see that I've kind of got these 2 shapes individually just sort of stuck on to one another. So in this case, I'm going to be adding my volume. So I'm doing the cylinder plus the 2 spheres. So I've got 848 point, I'm just going to write 23 now instead of all the zeros, plus the 226.1647. And then I put that all in my calculator. So first get an answer of 1074.3947, but I'm just going to round it to 2 decimal places as 1074.39 centimeters cubed. So again, the important thing is that when you are doing volume, you do a little bit of extra decimal places compared to your final answer, just because if you round a little bit too much early on, it's going to affect that final answer and it can be off by 1 or 2, but that could be the difference of a mark in an exam. Okay, so let's take a look at another question then. So here, the shape below is a large square-based pyramid. So I'm going to highlight that. So firstly, I've got a large square-based pyramid with a small square-based pyramid. And then I've got this keyword is removed from the top. So the fact it says removed instantly tells me I am subtracting these volumes. So we're told the large pyramid has a height of 18 centimeters and the length on the bottom is 5 centimeters. And our small pyramid has a height of, and I didn't actually write that in, should be 8 centimeters in there. Just about squeezed it in. Height of 8 centimeters with a base of, base length. Ooh, that's messing this up. Base length of 2 centimeters. Calculate the volume of the shape. So to start off with, we want to just find out the volume of each shape individually. So first, let's do our large pyramid. So we're given the formula of a third times the area times the height. So we've got a third times, so I'm told that the base length is 5 centimeters, and because it's a square, that means all the sides on the bottom is going to be that 5 centimeters. So that's my area, and I'm told the height is 18. So multiplying that out, and that gives me 150 centimeters cubed. So then I want to find out the volume of my small one. So in my small one, I'm told that the base length is 2 centimeters. So that means all the sides are going to be 2 because it's a square. And the height of it is 8. So multiplying that together, and that gets me 10.66666, and that goes on forever. And just watch out, because in this one, on my calculator, it gave me an answer like this. Always look out for that dot, because that means that number reoccurs forever and ever. So I've got 10.66666, and it goes on. So that means then my total volume, again, because I've got that word removed, I know I'm subtracting, and so I have to do my large take away the small. So I've got 150 take away 10.66666, and so forth. Which is going to give me an answer of 139.33, and it'll be in centimeters cubed. Okay, so last one then. So the shape below is made from a hemisphere on top of a cone. So I'm going to highlight the fact that I've got a hemisphere and a cone. The height of the cone is 12 centimeters, and the height of the would help if I can spell height. That's my dyslexia coming through. And the height of the total shape is 20 centimeters. So height total, 20. Find the volume of the shape. So to start off with, we have not been given a volume. In both of our formulas for both the cone and the sphere, I need to find out what the radius is. I said volume a moment ago. I need to find out what the radius is, and I'm not being given them in either part of the question, not in the diagram and not in the written part. So I need to try and work that out. And the best way to do that is to try and figure out what this height here from the very bottom of my sphere to the top of my sphere. Because I think if I know this height, that's the center of my sphere to the edge, and that means that's my radius. And whatever that height there is, that's also going to be the radius of the sphere as well as the cone. So all I need to do to figure that out is I take the height of the total shape and I take away the height of the cone, which is going to give me 8 centimeters. So my height here is 8 centimeters, and that means my radius of both shapes is going to be 8 centimeters. So now I've got that information, I can now figure out what the volume of my hemisphere and my cone is. So let's do the hemisphere first. To start off with, I'm just going to find out what the volume of a whole sphere is. Got 4/3 times, I'll write my formula first. Pi r cubed. So that's 4/3 times pi times my radius of 8 cubed. Which gives me an answer of 2,144.6605 and so forth. And so that means my hemisphere again, remember I just half it. So I take that number and I just divide it by 2. Divided by 2. So that gives me an answer of 1,072.330. I'm just going to round that up to 3 there. And then I got to do my cone. Don't want to go too far over. So my cone, using my v equals third pi r squared h. So I've got third times pi times 8 squared times the height of the cone, which don't get it confused with the total height. It is just that 12 centimeters there. So sticking that into my formula. Gives me an answer of 804.2477. And so my total volume, I can see that I've just got these two sort of shapes and they've just all been stuck together. So that means I'm adding them. So I'm doing the hemisphere add the cone. So I've got 1,072.3303 add the 804.2477. Getting a bit squished. So I just add it on. So that gives me a final answer of 1,876.58 centimeters cubed. Let me know if you have any questions about this at all. I hope this sort of makes sense. This is definitely the trickiest part of volume. But yeah, good luck with the work and let me know if there are any issues.